Document halos are not only the building blocks of the large-scale structure in our universe, but also the birthplace of galaxies, so they are quite important. Most of our current knowledge about dark matter halos come from numerical simulations, in which dark matter is modeled with collisionless particles. Basically, there are three perspectives to investigate dark matter halos. The first one is the halo structure, or what is inside halo. For each halo, we can investigate its radial profile, its non-spherical shape, its rotation, and the substructures. The second perspective is from the temporal dimension, which is the assembly history of dark matter halos. So for each halo, we can find its progenitors split to multiple halos recursively, so that its assembly history can be described by a tree structure. Apparently, this tree structure is too complex to be understood or be incorporated into theoretical models, so we need to reduce the complexity by data compression. A common strategy is to extract the main branch by recursively selecting the most massive progenitor halo, so it will produce a linear structure called the mass accretion history, from which we can define a characteristic halo formation time. So the last perspective is the spatial distribution of dark matter halos, or halo clustering. One important thing to remember is that dark matter halos are randomly but not uniformly distributed in our universe. Instead, they are clustered, and the clustering strength depends on a variety of halo properties. The primary dependence is on halo mass, which is called halo bias. We also found many secondary dependencies on other halo properties like concentration, spin, and substructures. They are collectively referred to as halo assembly bias or secondary halo bias. Combining these three perspectives, we can find a lot of interesting things of dark matter halos. For instance, halo assembly bias is found by combining halo clustering and halo structures or halo assembly, depending on which halo property in consideration. In addition, there are many models trying to predict halo structures like halo concentration and substructures from the assembly history, and these models are very successful.